Welcome to Dr. Subhash Technical Campus. As a part of the subject complex variable and partial differential equation, we will discuss on the topic homogeneous partial differential equation. In case 1, 2 and 3, we have already studied different cases for the function fxy not equal to 0. We will proceed towards case 4 and case 5, that is when f of xy is equal to x raised to m y raised to n and e raised to ax plus by into v. First, let us revise some of the notations. Our given equation will be of the term of the form f dd dash z equal to f of xy. When f of xy is not equal to 0, we need to find particular integral, and the equation will be pi equal to 1 upon f dd dash f of xy, and the general solution can be given by z equal to cf plus pi. Now we'll see once quickly what are the notations. D square notation gives the partial differentiation with respect to x. The operators d dash square gives the differentiation partially with respect to y. The inverse operators 1 upon d square gives the integration partially with respect to x, and the inverse operators 1 upon d dash square gives the integration partially with respect to y. These are the basic notations which we have already seen in my previous lectures. Now we have already learned the first three cases. First case was e raised to ax plus by. Case 2 was sin ax plus by or cos ax plus by, and case 3 was about ax plus or minus by or tan ax plus by or log ax plus by. Now we'll move towards case 4 and case 5. Case 4 is if the RHS term is x raised to m into y raised to n, where m and n are positive integers. We will use this general formula for pi, and we need to remember this binomial formulas. 1 plus x inverse will be 1 minus x plus x square minus x cube plus so on, and 1 minus x inverse will be equal to 1 plus x square plus x cube plus so on. Now let us understand this case by solving some examples. Example 1. D square minus 2dd dash plus d dash square z equal to 12xy. See, here we can see from RHS side that it is of the form x raised to m y raised to n. Now the auxiliary equation can be written as m square minus 2m plus 1 equal to 0. This is equal to m minus 1 whole square, and this implies m equal to 1. Here the roots are real and equal, so CF will be 5 1 y plus x 5 2 y plus x. Now we will find pi. Pi will be, first we will write in terms of d and d dash, and here we are writing the RHS part. Now this 12 I am taking here common. Now here the procedure is we can either take common as d square or either we can also take d dash square as common. Here I am taking out d square common from the denominator. Okay, so the rest two terms will be divided by d square. Now this term I am keeping as it is for a purpose. Now here this d and d will get cancelled and minus sign I am taking common, so I will be remain with 1 minus 2 d dash upon d minus d dash square upon d square. Since it is in denominator, when I am taking to the numerator, I will put here inverse sign and this xy will be remain as it is. Okay, now according to the binomial theorem, 1 minus x inverse can be written as 1 plus x square dot dot. We need not take many terms, it will be enough if we take one or two terms. Okay, so now I will multiply this xy with these three terms. So here I will get xy. Next term I am multiplying this xy to the second term and multiplying xy to the third term. Now this xy will be as it is. First I am integrating with respect to x, since we are having d at the denominator, so I am integrating with respect to x. I get x square by 2y, and here if I integrate it and then differentiate it with respect to y, then the term will become 0. Okay, and see this term again I am keeping as it is, and now since here it is d dash, I will differentiate this term with respect to y, so x square by 2 will be as it is and y will become 1, and this 2 and 2 will get cancelled, so only x square will be left. Now we can see here that there is 1 upon d square outside the bracket, so we have to integrate this portion with respect to x 2 times. First I am taking 1 upon, I am putting 1 upon t as it is. Okay, I will integrate one time, so I get x square by 2y, and this x square will become x cube by 3. Again I will integrate, so I get x cube by 6y plus x raised to 4 by 12. So there are no terms of d and d dash now, so z will be equal to cf plus pi, where cf equal to 5(1)y plus x 5(2)y plus x plus pi, what we have obtained above. So this is my general solution for the given differential equation. Let us move towards one more example. Find the particular integral of d square minus 9d dash square z equal to x square y. Now I have to just find particular integral, so there is no need to find CF. So for particular integral, we are writing 1 upon d square minus 9d dash square x square y. Now as I said in above example 1, we can either take d square common or d dash square common. So I am taking here d square common. So inside the bracket I will be with 1 minus 9 d dash square upon d square. I will take to the numerator portion, so this will become inverse. Now again I will use binomial theorem. According to binomial theorem, 1 minus x raised to minus 1 will become 1 plus x square plus dot dot dot, and this x square y will be as it is. Now I will multiply this x square y with all the three terms. So here I will get x square y. I will multiply this x square y with second term and again with the third term. Now when I this x square y will be as it is. Now when I differentiate this term 2 times with respect to y, okay, when I differentiate this second term 2 times with respect to y, since it is d dash square, so I will get 0 here. And similarly, when I differentiate this term 4 times with respect to y, I will get as 0. So these two terms will become 0 and I am left with the term x square y. Now here I am having d square, so I have to integrate this with respect to x 2 times. One time I will get x cube by 3y, and the next time when I integrate this again, I get x raised to 4 by 12y. So this is my pi which is asked for the given differential equation. So this was about case 4, when we are having RHS as x raised to m, y raised to n. Now let us move towards case 5. Case 5 is when fxy equal to e raised to ax plus by into v. Now v can be any of the function, either of case 2 or case 3 or case 4. Now we will understand this. See what we have done in pi. What we have to do is we have to replace d by d plus a and d dash by d dash plus b, and we will take e raised to ax plus by to the LHS of the given term. We will understand it by some simple examples. See, here it is del square u upon del x del t. Here our function is in the form of x and t, equal to e raised to minus t cos x. So the given equation can be written as d dash u, because our function is u, and RHS term I am writing as it is. Auxiliary equation will be m equal to 0, so CF will be phi of t plus 0x, which is equal to phi of t. Now for pi, I will write 1 upon d dash, and the RHS portion will be as it is. Here the coefficient of x to the power of t is 0 and coefficient of t is minus 1. So a will be 0 and b will be minus 1. I will take this e raised to minus t to the LHS part, and I will replace d by d minus 0 and d dash by d dash minus 1. So I get 1 upon d dash minus 1 cos x. I am multiplying this d inside, I get d dash minus d. Now see, now this is becoming case 2, which you need to refer. In case 2, for d dash we write minus ab. So here a is 1 and b is 0. So this term will become 0, and I am left with the term 1 upon minus d cos x. Now 1 upon d means integration of a function with respect to x. So integration of cos x will be sin x. This minus is already here, and this e raised to minus t term will be as it is. So the general solution will be CF plus PI. This is my required general solution. Let us take one more example. D square minus d dash plus 2d dash square is equal to e raised to x y minus 1. See, now the auxiliary equation here is m square minus m plus 2 equal to 0. By splitting the middle term, we can write m minus 2 m plus 1 equal to 0. So m will be equal to 2 and minus 1. Roots are real and distinct, so CF will be equal to phi 1 y plus 2x plus phi 2 y minus x. Now we will move towards PI. See, PI will be, I am writing this term from the question as it is, and this is the RHS term. Now here the coefficient of x is 1, so we need to replace d by d plus 1, and coefficient of y is 0 to the power x, okay, to the of the power e. So d dash will be d dash minus 0, that means only d dash. So e raised to x will come to the LHS side of the given term, and I am replacing d by d plus 1, and d dash will be as it is, because d dash can be written as d dash minus 0. I will open the first bracket, a plus b whole square, so a square plus 2ab plus b square. This d dash I will multiply with the bracket, so this will become minus dd dash minus d dash, and this term will be as it is. Now again I can rewrite this equation in this way. I am putting 1 here outside, and the rest of the terms I am taking together, okay. So now taking this whole term to the numerator portion, I have to put inverse sign. Now this is becoming x raised to m y term, okay, x raised to m y raised to n like term. We are using binomial theorem here. So this can be written as e raised to x will be as it is, 1 minus rest of the term and y minus 1. Now I will multiply y minus 1 to the each term inside the bracket. I am multiplying y minus 1 to the each term inside the bracket. So this here in this step I have multiplied y minus 1 to each and every term. So now let us simplify this. Y minus 1 will be as it is. Now differentiation of this with respect to x 2 times will become 0. Here differentiating with respect to x will become 0. Same way, when I differentiate this with respect to x one time, I will get 0. Here when I am differentiating with respect to y, I get 1, and again this part will become 0 when I differentiate y minus 1 2 times with respect to y. So this minus 1 will get minus 1 plus 1 will get cancelled. So the leftover term is y into e raised to x. So now there are no more terms of d and d dash. So the general solution will be CF plus PI. So this is our final required solution of the given differential equation. So there are total 5 cases for the equation when the RHS term is not equal to 0. So you might be clear with the topics. Thank you.